First thing in example 2, the textbook hasn't drawn them in. If you have your red pen, add an asymptote there, and an asymptote there, and label your asymptotes y equals 0 and x equals 0. Second thing that we're going to do is we're going to take the equation and we're going to rewrite it so that it's y equals, which means I'm going to move the 4 over. And I do a quick check, and do you notice that inside the function, the horizontal stretch and the horizontal translation is already written in factored form? That's important. Yes, Kat? Yeah. And then finally, moving the 4 over will give us a minus 4. Once I have the equation set up, so I had to take some time to move the 4 over, I also did a check that it was in factored form. Then I can go through and label each of the things. What is the 1/2? Horizontal, because it's inside the function. Stretch, because you would multiply your x values by 2. Second, the +1 inside the function is a horizontal translation. The +1 tells you that you're going to go 1 to the left. And finally, the -4 is a vertical translation. It's outside the function. You're going to move 4 down. So now we have our setup. To graph this, we'll take key points that are on our original graph. Okay? They've labeled some for us. Usually if they're labeled, those would be the ones you should use. So we're going to use the ones they've labeled. -2, -0.5. Oh, I don't like the ones they labeled. Can I switch? Do you want nicer numbers? So I think they should have chose 1, 1 and -1, -1. 1, 1, -1, -1. And we're also going to write down our asymptotes. We'll do those last. We'll do our points first. So, and we have stretches and translations. So we have to do 2 sets of brackets. How many stretches, compressions do we have? Only the 1. So above my first arrows, I will only do the x by 2. But with translations, I have 2 of them. I have 1 to the left and 4 down. Mental math-wise, x by 2, that's going to give me 2, 1, -2, -1, 1 to the left, 4 down, 1 to the left, 4 down, and we find out where our new points are. With the asymptotes, since both of these asymptotes started at 0, can you see that multiplying won't change them? Multiplying x by 2, that would only change the x one, but it's 0. The only thing that's going to change a vertical asymptote at 0 is if you move it left or right. Can you see that we're moving 1 to the left? That this asymptote is going to change to x equals -1. And the only thing that would change a horizontal asymptote is if your graph moved up or down. We're moving 4 down. We were at y equals 0. Shifting that 4 down will change this asymptote to y equals -4. I find, especially with graphs with asymptotes, they get very busy very quickly. So I would recommend, instead of drawing it on the same graph, when we go to sketch this graph, we just set up a new graph. Start by labeling your asymptotes. We have an asymptote at x equals -1, and we have an asymptote at y equals -4. I can now label my points. I have the point 1, -3, and I have the point -3, -5. Your graph has to go towards its asymptotes. And we have now drawn the new graph with all the transformations. So the reciprocal graph is fairly straightforward because you just need 2 points and your asymptotes to draw it. I'm going to add a part B to this question. Oh, I didn't finish part A. I should finish by reading the question again, make sure I answered everything, because I'm pretty sure they'd ask domain and range. Oh, they did. Great. The best way to do domain and range for graphs with asymptotes, there's an asymptote at x equals 0. So we write our domain is everything except x can't equal 0. The original graph had an asymptote at y equals 0, but everything else was included. So our range is y can't equal 0. In our blue graph, the domain now is everything but x can't equal -1. And the range is everything except y can't equal -4. Now, the part B, we're going to write the explicit equation for each graph. So the red one was given to us as y equals f of x. That's function notation. The blue one was given to us as y equals f of 1/2 x plus 1. Minus 4. Do you recognize the red graph from our colored papers? The red graph was 1 over x. So in a sense, the function part is 1 over x. Yes?
Because of the asymptotes, aren't the points supposed to be like 0, -3 instead of like 1, -3?
Yes, if there wasn't a stretch. Okay? So Eliza made a good point here. She's saying, I see how this 1, 1 is like 1 away from the corner? And the -1, -1 is 1 away from the corner? Shouldn't they also still be like 1 away from the corner here and 1 away from the corner there? And the answer is yes, if there's just translations. But as soon as we start adding stretches, then things go off a little bit. So good observation, but the reason it's not perfect that way is because of the stretches, okay? Also to make good observations like that, because I promise you, I will make mistakes. Not on purpose. They happen, okay? You will make mistakes. Not on purpose. But sometimes I'll make a mistake, and you'll be like, shouldn't it be here? And I'll be like, absolutely. I made a mistake. I'm sorry. So never feel like, if you're unsure of something, to not say, hey, check that out because I want to know why. But if it is in the right place, we can explain like why it is there. And here, of course, we do have a horizontal stretch. So being 1 away, stretch to being 2 away at that spot. So if our explicit equation for the red one was our 1 over x graph, how do we take function notation and switch it to explicit notation? Well, it will look like this. Y equals. What does the function do? It says wherever there is, whatever's inside the function replaces the x. Do we have stuff inside the function? Now, this is all inside the function. That means that will all be where the x was. This minus 4 is outside the function. That minus 4 will be after the function as well. So this could be a question you get. We got this question in this form, where it said, here's the graph, deal with the function notation. You could get this same question with just this. Can you graph this? If it said, can you graph this, your head would have to say, hey, this looks like a 1 over x graph with the x replaced with this and a minus 4 outside afterwards. Some students, when they see this, they like to change it back to function notation to be able to it's easier to see all the stretches and compressions in function notation than it is sometimes in the explicit notation. So I'm just giving you opportunity to see both of those. Okay. Ooh. If I could get a sponsor for this question. Homework 7-Eleven. Right? It's on. I should get like free Slurpees for doing that on video on YouTube. Like all 2 people that are going to be watching this are now also going to buy Slurpees. So I think I deserve my cut.